So we have been solving systems of equations. A system of equations is two or more equations that work together, and we have looked at linear equations so that when we graph these equations we get lines. So today the question we're asking is, how many ways can two lines cross? We've seen a bunch of examples where they cross one time, right? But is that the only possibility? So you see this little cartoon look here about two arms. So think of your arms as two lines. You can hold your arms such that they don't intersect, right? Such that they never cross. And if two lines never cross, we say that there are no solutions. This would be, of course, parallel lines. Parallel lines are never going to cross, okay? Or, and this is what we've seen the most of, your arms can cross in one spot. If they cross one time, that is one solution, and those would be called intersecting lines. Now, this next one's a little weird to think about, but think about if you placed your arms one on top of the other, where they overlapped everywhere. Everywhere you touched was on both of your arms at the same time. That would be an infinite number of solutions, and that would be that those two lines are actually the same line, okay? And we're going to look at these in two different situations. We're going to do this by graphing, and we're going to do it by substitution. So here we've got two linear equations, y equals negative 2x minus 1, y equals negative 2x plus 2, and we're going to graph these two lines. Okay, so we graph the first one. The y-intercept is negative 1, and the slope is negative 2 over 1, so I'm going to go down 2 over 1. I'm going to fill up my coordinate plane, and I get that line. Okay, the second one is y equals negative 2x plus 2. So I'm going to do my slope-intercept of 2. I'm going to do my y-intercept of 2. My slope is still negative 2 over 1. And what happens? They don't intersect, right? So how many solutions does this system have? It has no solution, okay? Notice they're parallel. And notice something else. They have the same slope, the negative 2, but they have different y-intercepts. That's a clue that there's no solution. The same slope, parallel lines have the same slope, but a different y-intercept, so they start in a different place. They don't intersect. All right, the next set of lines is y equals negative 1/2 x plus 0. So that goes to the origin. My slope is 1/2, so I'm going to go up 1 and over 2 and up 1 and over 2. I'm going to do it again and again. And there's the first line. And then the second line is y equals negative 2/3 x minus 1. So my intercept is negative 1. My slope is negative 2/3. I'm going to go both directions. Okay, and there is my second line. Okay, so what is the point of intersection here? Or is there a point of intersection? There is a point of intersection, so we say that this system has one solution. Notice that the point here, we don't really know what the coordinates are because it sort of meets like in the middle here. We can't really tell what those coordinates are. We don't care. All we know is that they intersect and they have one solution. All right, last one. We have y equals negative 2x plus 2. So my intercept's my intercept's positive 2. My slope is negative 2 over 1. I'm going to graph that first line. And then the second line is what? The second line is y equals negative 2x plus 2. Start at positive 2 for my intercept. I do my slope of negative 2. And these are the exact same line. They intersect everywhere. Everywhere you can think of on this system is a point of intersection. So we say that this has infinitely many solutions. And as we talked about a minute ago, they're the same line. They have the same slope and the same y-intercept. Okay, so what does this look like if we have the two equations we're not going to graph and we want to solve by substitution? Remember, they both equal y, so we're going to take the 2x plus 3 and we're going to set that equal to the 2x minus 1, right? So 2x plus 3 equals 2x minus 1. Now, you should remember from what we did before we did systems, I have the same coefficient, right, 2, but I have different constants. Now we're talking about lines. I have the same slope, but different y-intercepts. So what would you expect here? You expect that there would be no solution. Same slope, different y-intercepts. Let's see what it looks like algebraically. I'm going to subtract 2x from both sides, and I get 3 equals negative 1. How often does 3 equal negative 1? Never, right? 3 does not equal negative 1. So we would say this is no solution because we got something that was never true. But remember, you already know what to expect because they have the same slope, different y-intercepts. These would be parallel lines and they would not intersect, okay? The next one, you have y equals negative x plus 1 and y equals negative x plus 1. Well, that's the exact same equation, right? So these are the same line and there would be an infinite number of solutions. But let's see what it looks like algebraically. I'm going to set negative x plus 1 equal to negative x plus 1. Well, I see a minus x and a minus x, so I'm going to add x to both sides. And I'm going to get 1 equals 1. How often does 1 equal 1? Always. So this is always true. So there's an infinite number of solutions. Infinite solutions. Because it's the same line. They intersect everywhere. Okay? The last one, I see two different equations, so I expect that I do get a solution here. Let's see what it looks like. I'm going to set negative x plus 4 equal to 4x minus 1. So my minus x is smaller, so I'm going to add x to both sides. And I get 4 equals 5x minus 1. I'm going to add 1 to both sides. And I get 5x equals 5. I'm going to divide both sides by 5. And x is 1. And when I get an x value, remember I can also get a y value. So I'm going to say y equals 4 times 1 minus 1. So y equals 4 minus 1, which is 3. So I get the point 1, 3, and this has one solution. If I get a point, that means they intersect. So that's your 3 possibilities. You can have no solution, infinite solutions, or one solution. You're ready to do some practice.